Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to the NPTEL online certification course on structural systems in architecture. Today we will start the module 7, that is the week 7, and the week 7 we will discuss the tensile and the plate structure. So the first 3 lectures will be on the tensile structure and the last 2 lecture on this week will be on plate structure. So today we will start the first lecture of the week 7, that is the module 7, and the topic of this lecture 31 is cable supported structure. So in this lecture I will going to cover the 4 concept. I will initially start with the tensile structure, the structural concept and the principles, and then we will do some numerical problems solving on the basis of the funicular polygon, and after that we will discuss some of the curvature of single and double curvature cable systems and their applications, and finally we will end this particular lecture in the with the multiple cable supported system. So the 2 learning objective of this particular lecture 31 will be we will outline the structural concept of the cable, particularly in the domain of the cable supported structure, and will illustrate the parts and functions of the various parts and functions of the cable supported structure. Now when we thought of any kind of a tensile structure which is kind of a flexible and non with the that system is made up by the flexible and the non rigid matter. The tensile structure actually will going to form such a way that it will try to stabilize the overall forces in that particular system. Then the stabilization of the forces will occur, and as and when it will be occur, it will develop a particular subject to a particular typical kind of a normal force or normal stress called tension. So through the tension or the tensile stress, a total system of the structural system will going to stabilize the action, and as you all know, this is one kind of the form active structural systems. So to begin with a particular small introduction of the cable structure, I have taken a very simple or the simplest type of cable structure where a cable is hanging from 2 supports, and those cables are inclined in nature, and it is a symmetrical case. It is under a load P, and this inclination is angle theta to horizontal. So by virtue of the if I now suppose if we do some free body of this particular part, if I draw the free body, so it has actually 3 forces in that point applied on this point, 2 tensions of equal in nature and opposite in direction, inclined at theta degree with the horizontal, and a downward force P. Under this particular 3 forces, you can divide the resolve the force, this T, this is the unknown force T, and this T cos theta and this T cos theta of the 2 sides will cancel each other. So I am left with the 2 T sin theta, which must be equal to this the force P, downward force P. So I can write that the T equal to P by 2 sin theta. So from this equation there are some interesting conclusion may be drawn. The first conclusion is that if we can have the same span, that is L is fixed, as and when the sag is higher, sag means this S is higher, as and when this S is higher, the angle of theta will be the higher, theta angle will be higher, because the tan of theta will be higher. So, as the theta is higher, the sin theta is also higher and the T will be lower. So, more the sagging of the cable, the lower value of the cable tension will going to appear. So, this is one of the most fundamental the point that we should know before we start with. So, in refer to the earlier one, the span and the sag is defined as the support to support distance is the span and the sag is the lowermost tip of the cable to the particular line of the span, line of the support, that is the span. Generally, we keep this particular sag and to span ratio is almost about 1:8 to 1:10. That means if the sag is 1, the 8 times will be the 8 to 10 times will be the span of that particular cable structure to make the tensile or the tensile force in a limiting order. Now, what we have discussed till in the last example is a force in one typical force, external force applied in a cable. Now, if I increase the number of forces, suppose that there are two such forces, sometimes there are 3 or maybe more. As and when we will increase the number of forces, this triangle will start moving with and finally go to a polygonal shape. Breaks, there are small breaks in the cable, and this particular shape that exists because of the different loading and different loading in the different point of the cable, and that particular shape is called the funicular shape. And this is one of the extremely important shape in the case of a cable supported structure. And again, each and every part of this cable, suppose if you take this or maybe any kind of cable, any cable in any position of that funicular polygon will be under pure tension. And now, if I instead of that particular the force, that external force, if I now put that particular cable with its the own weight, that means it is not under any kind of external force, it is own weight, then this particular the shape will take a mathematical kind of a shape, or that shape can be represented by a mathematically with a hyperabolic function. We will discuss in the next class in that or next lecture in that, and that shape is called catenary. Suppose you just hang a particular chain which is given in the right side figure, the shape it will be created for its own weight. See, I have not put any kind of the load over there is no load on own weight and under gravity, it will give a very smooth kind of a shape which is a catenary. But please remember that this catenary is not parabola. Parabola can be drawn, suppose in this funicular polygon, if you increase the number of loading and each loads are equal to each other and very congested one to each, and those external load is too high with compared to the weight of the self weight of the cable, then only it will lead to a parabola. So, let us solve some of the numericals over here. So, I have taken a funicular polygon with two such forces P, and those are the at A and at B there are supports, and as you know, these supports will have reactions, the V A and the V B, and there will be two reactions also, the horizontal reactions H A and H B, but this H A and H B will be equal because otherwise there will be imbalance in the x axis direction. So, here we can have some unknowns, or the support on reactions may be unknown, or the tensile forces are the unknown. So, from the symmetry we can say the V A and V B is equal to P, because there are the forces are twice P downward and it is symmetrical. And if I take the free body diagram at part C, at particular point C, this is the free body diagram, and if I take the left part, then I can equate, and at point C the moment equal to 0, and I equate it, and I can find out the how much is the H, because this, if you see the H dc is the moment created by the H, because of this is separated by a distance dc from C, and it must be equal to the moment generated by the force VA, this A, and that is at a distance L1. So from that I can find out the value of H. So VA, VB and H can be computed, and similarly from the free body at C, this is the free body suppose at the point C, we can easily find out the forces in the cable, the tensile forces in the cable, that is written over as a TCA, that is the cable CA, the tensile force, and the TCD, the cable CD, we can find out. So if I now take the same problem with the values, that P equal to 15 kilonewton, L1 is your 3 meter, L2 is 4 meter and all, then we can easily solve the equation. So from the symmetry I may know that I can understand that these reactions will be your the 15 kilonewton, and suppose if I take the moment about C, the HA into 1 meter, HA into, so this will be the HA into 1 meter, this DC is equal to 1 meter, L1 is equal to 3 and VA is equal to, already I know it is 15. So the HA can be computed as a 45 kilonewton. Similarly, I can find out all the forces by the free body at particular point. This is the point C. So I have computed all the tan theta. Tan theta is 18.4 degree. Why? Because this angle is the theta, this angle is the theta. So this is the tan of theta will be this 1 by 3. So I also find out the corresponding value of the sine and cos theta, and with this equation if I put and if I try to find out the values, I can find out the values as TC is 46 and TCD is 44.3. Of course, one thing is very important, that the tension of this must be equal to tension in this because of the symmetry. Now let us take another problem where this polygon is in different order, the different order in the sense the two forces are now different, 20 and 10 kilonewton. Their distance, of course, they are equally distance apart, 3 meter each, but the supports are not in the same level. One support is the B, support B is almost 1.5 meter above the support A. So I now need to find out I know, and this sag length is 1 meter at that particular points it is given. So now I need to find out what are the tensile forces in the cable, and also first I have to find out what is the sag at D, that is also unknown. So so if I take now moment about B and put it equal to 0, that means this. So from that point of view, all the forces are coming to my picture in this moment equation. So this VA is at a distance of 9 meters. So VA into 9, that gives the moment in this direction, and this 1.5 into H at this point, the HA will again create a moment in this direction, which is HA, and distance between the point B to this line is 1.5 meter, and must be equal to the moment generated by this points load at C and load at D, that is 20 into 6 plus 10 into 3. So this is the first equation. And if I take the free body at C, and I can find out what is the relation between the VA and H, then the 1 into H, because 1 is this distance, into H. So that is this moment, and VA into 3, which will give me the the equations 2, and this equation 2 is now used to find out the values with the help of the equation 1, and then I can substitute and then find out those two values of the VA and VB, and gradually I can find out how much is the value of even the H also can be found out, and finally I can find out the value of DC by taking the free body at D and this part. So the DC, you see, that's thrice into VB. So this particular moment must be equal to moment generated by H into 1.5 plus DC. Why 1.5 DC? Because from point D, this H is separated at a distance dd plus 1.5. Out of that 1.5 is known, so I can easily find out the dd at 0.2 meter. And we can now go to the each joint C and the joint D. You can calculate the angles and cos and the sine component and find out the forces CD and the CA in these two member. And also you can go to the joint D and do the free body diagram and find out the angles beta and the gamma. The beta angle is this angle and the gamma angle is this angle. Earlier this angle is beta and this angle is alpha. So those angles and the from the geometry everything I know, so I can find out that, and finally I can find out the tension at dB also. So the funicular problems, funicular polygon problems can be solved by virtue of the just force balance and the moment, which we have known from our beam calculations and the analysis of beams, and it is very simple also. Now let us go to the next, where let us discuss about the single and the double cable curvature also. In this particular cable, if it is you see there are three such component. The first one is called the suspension cable, which is the long cable which is going to suspend and take the load by virtue of some the other supports reactions also. And there are gay cables which is going to be also, it is called stay cables, which are actually connected with the suspension cable, and a neutralizing kind of a force is acting towards the ground. And the third component is the column, that is the central column, which is called here mast, and this mast and should be in compression. The cables will be in tension, both the stay or gay cable or maybe the suspension cable are in the compression, I am sorry, the tension, and the mast will be definitely under the compression. But when you design the single cable, so a particular the roof can be over that, or this can be a roof, this portion can be a roof, and we can take support from this particular cable. And if I take the suspension cable support like this, this will be creating a funicular polygon. So that's the the interesting thing is that suspension cable sometimes can have a catenary, because if you just leave it with its own weight also and put the roof over there, or sometimes it may go with a funicular polygon, then we are taking the pointed load from the below. But the problem with this particular one single cable is that it will be very prone to uplift when there is a wind, the wind is generated, and that will be creating a serious kind of a concern if it is a very lightweight structure. And this kind of tensile structure basically is a lightweight structure, and the problem will occur in that cases. So the gay cable will absorb the horizontal thrust, transfer the load to the ground, and the mast is under a compressive force designed for buckling and all those, as you know, it is a column member. Now here you see the gay cable, if I put this particular mast perpendicular, so you know that in the gay cable and the suspension cable the forces will be typically in this two direction. So the resultant will be like this red color this red color arrow. So what happened is this red color arrow with respect to the mast, it will invite a bending, because see this red color arrow is not along with the axis of the mast. So definitely it is eccentric, it will invite some kind of a bending. But if I go with inclined mast, such a way that the inclination of that is such a way that because of the tension in the cables, that is the suspension cable and the gay cable, the reaction passes through the axis of the mast, then this reaction is axial, no bending occur. You can have very economical or the slender design for the mast. So it is one of the fundamental, that is why this the mast sometimes is kept inclined, not perpendicular or perfectly vertical. So this I have already told, this kind of the cables are under some kind of a load, and this particular suspension cable is under tension. You see these are all tension. This A cable is also under tension, but the mast is all under compression. So, in case of the double curvature, the benefit is that the upper curvature. So, this is the upper curvature. This upper curvature will take care of the gravity, and the lower curvature will take care of your wind kind of scenario. So, this will going to be take care of your wind, this too. If you go with this kind of a form, and this will take care of your, this upper curvature will take care of your gravity. So, this is the wind and this is the gravity, this is the wind and this is the gravity, and this structural system is more rigid to take care of the wind flutter. So, in this case we have sometimes or many times we have to link these two cables. When there is a double curvature cables, you have to link, and those links are called separated or stirred, because those are also come under compression. So, here we have two cables. So, we have two names also. The primary cables are cables which are taking care of your gravity. So, these two are the primary cables. This is the primary which is taking care of the gravity. This is primary taking care of the gravity. This is secondary which is your taken care of the wind, and this is your secondary which is taken care of your wind. So, this is one of the figure in industry. You see how the particular roof is been supported by the supporting cables, and then this is backstay cables, which is this, which take care of the resolving or the neutralizing the forces, and also this is having the supporting cable, some of the supporting cables, and finally there are mast, that is the central pillar which is actually taking care of the column the compression, because you see in a particular system other than the tensegrity, this system will have some component which has to take the compression. So, mast actually take care of the compression, and there are anchorage also at the end of the stay cable. So, the multi cable systems are also there, where instead of the one cable we can use the multi cable. Of course, the last photograph or last figure whatever we have seen, there are multi cable systems, but multi cable in the sense of that what we have will discuss now is there are type of multi cable which are there because of the different type of the deck and the pylon that supporting both. In a particularly it is applicable in the bridges where there is the cable stay bridge also, but instead of the bridges also we can use it for some stadium or some of the airport, or maybe some of the arena where there are large column area has to be covered with the column free kind of a constructions also. So, the multi cable systems has four types. The first one is radial. In the radial system, as you understand from the left figure is that right figure is that there is a deck and there is a pylon. So, the vertical is the pylon and this is your deck. So, deck has to be supported, and deck is cantilevered out. So, it has to be supported by even cables which are actually connected in the deck at a uniform distribution, but they are actually pointed or connected at the top a single point and converge from the deck to the pylon or the pier. So, this is called the radial system. This is called another system is the left hand side figure is the HERF system. The basic difference is that the deck, yes, it is taken from the different point of the deck and they are well distributed, and after it takes care of that, it is not going to converge, it is a parallel kind of system, and in the pylon or the pier there are again that is also equally distributed, and it has connected in different height in the pier. So, these two are the HERF and the radial system. We will discuss in the third lecture how this system generate forces and what will be the economical way to handle the forces also for any kind of the architectural applications also. We will discuss in the lecture number 33. Other two systems are, the one is fan system, where you see it is something like a combination of the radial and harp, where it has taken from the various points of the deck uniformly distributed, but also it is attached in the different point in the pylon in the vertical level, but it is converged towards the top. It is exactly not going to converge in the same point, but it is converged towards the top. See this particular, the distance, the next distance is smaller, or this distance is smaller, like that. And the last one is the star. The star is just another reverse kind of a scenario, where the cables are till now what we have seen is that we put the deck, there are a lot of points, the divisions in the deck, but here we take the load of the deck from a single point, but we distribute the connectivity at the pier level in various or equal the spacing different vertical levels, and that create another convergence not in the pylon, but in the two extremities at the deck. So we can say that the star is almost the reverse of the radial kind of a thing. So these are the reference I have took for this particular lecture, and the conclusion of this today's lecture is that the cable supported structure is one of the structure that we can use for large arena. It is extremely effective kind of a structural systems, and it's practically actually going to support the building roof, and this particular cable supported system can be analyzed by through the polygon, this funicular polygon approach. The load path mechanism shows that the structural element of this cable supported system is mostly tensile, except for one or two. The mast is always going to be in compression, but other cables are definitely will be under tension. So this tension has to be taken into account, that how much tension that a particular the cable can be bear according to its permissible stress or so. So we have some homework for you today. The first homework is that again I have given a funicular polygon, symmetrical of course, and those three loads are 10 kilonewton each, 10 kilonewton each, you see, and the cables are each horizontal segments of the cable are 2 meters. So these all are 2 meter. 2 meter. The sag at point C and at point D are also mentioned as 0.5 meter, and these all are the 10 kilonewton. So based on this particular input dimensions and the input data, you have to find out the support reactions, that is you have to know what is your VA and VB and H. Here also the H will be equal for A and B, and you have to find out how much is the sag here at D, and you have to find out the tensions in each cables. So if you can find out this two, if you analyze the point C and point T, it is done because it is symmetrical. So whatever the tension here T dash will be equal here, and this T will be equal to this T. So this is the first this thing, and the second one is that as we discussed in the very first example, there is a cable which is inclined at 45 degree, the theta is 45 degree, and this P equal to your 10 kilonewton, and this is your 45 degree. So you have to determine the diameter of the cable required for support, because how much is the diameter you have to find out. The permissible tensile stress is 500 ampere, that means 500 Newton per mm square. So, first you find out how much is the force, and then you found out how much area is required to take care of that. So, that is all for this lecture number 31. Thank you very much.